Do you want to be able to calculate the relative molecular mass of any compound? Well, in this video, I will not only show you how to calculate the relative molecular mass, but also the mole and the percentage composition. Hi, I'm Wisdom Richman. On this my channel, I share short videos easy enough to give you understanding of your science topics. If you consider subscribing this the first time on my channel, and don't forget to turn on the post notification. And even if you are not a science student, I promise you are going to benefit from my videos. For example, the video I made on the separation techniques. If you have not watched it, go and watch it. I will link it in the description below. Okay, now the business of the day. So what is relative molecular mass? Relative molecular mass is the sum total of all the masses of the element contained in a molecule of a compound. Okay, how do you get the masses of the element? You get the masses of the element from the periodic table, or it can be supplied in the question given to you. But I recommend that you memorize the masses of the first 20 elements, since they are the custom elements in most compounds. Okay, and some examination boards may not provide them. Okay, let's go further. Let's say oxygen. The number of atoms in oxygen is 8, while the mass number is 16. But this may be contrary to what you see in your periodic table, because they give the atomic number at the top and the mass number at the bottom. But this is not the correct way. It is only classified that way for easy classification. But the correct way is to put the mass number at the top and the atomic number at the bottom. So A is for mass number and C is for the atomic number. Okay, let's go further. Okay, let's say I'm given a question like this. Calculate the relative molecular mass of sodium tetrahydrosulfate 6. Sodium tetrahydrosulfate 6 is Na2SO4. The mass of sodium is 23, while the atomic mass of sulfur is 32. The atomic mass of oxygen is 16. So since there are two atoms of sodium in this compound, we are going to say 23 times 2. And since there's just one atom of sulfur, we are going to say 32 times 1. And that of oxygen is 4, so we are going to say 16 times 4. So 23 times 2 is going to give us 46. 32 times 1 is going to give us 32. And 16 times 4 is going to give us 64. So when we add all of them together, we are going to get 142 grams. So that is the relative molecular mass. Now that we are done with the relative molecular mass, let's go further into the mole. So now, what is a mole? No, not that kind of mole. Yes, that kind of mole. A mole is the amount of a substance that contains 6.02 times 10^23 particles. Let's say this is tetrahydrosulfate 6 acid, and without any coefficient added to it, I can say this is 1 mole of tetrahydrosulfate 6. But if I add 2 to it, it is going to be 2 moles, and if I add 3, it is going to be 3 moles of tetrahydrosulfate 6. So you get the logic. Yeah, so that's what we call a mole. So now, how do you calculate the mole? You calculate a mole by dividing its reacting mass by the molar mass, or its number of particles by the 6.02 times 10^23. Okay, I've been calling this number for quite a lot now. So what is this 6.02 times 10^23? It is called the Avogadro's number. Okay, let's test a few questions. Let's say you are told to find how many moles there are in 30 grams of calcium chloride. Since the mole is dividing the reacting mass by the molar mass, which is also known as the relative molecular mass, so we are going to find the relative molecular mass of calcium chloride first before we can find the mole. So calcium chloride is CaCl2. The mass of calcium is 40, while the mass of chlorine is 35.5. So since there is just one atom of calcium here, we are going to say 40 times 1. And since there are 2 atoms of chlorine, we are going to say 35.5 times 2. So 40 times 1 is going to give us 40. 35.5 times 2 is going to give us 71. And when we add them up, it's going to give us the relative molecular mass, which is 111 grams. So to find the mole, we divide the mass given in the question by the molar mass. That is the reactive mass by its molar mass. So we are going to say 30 grams divided by 111 grams. So we are going to get 0.27 moles. So that is how to find the mole of any compound. Okay, let's test a bonus question. Let's say you are told to find how many moles there are in 6.3 grams of aluminium. Okay, and also to find how many particles there are in 6.3 grams of aluminium. So the first question is to find the mole, and the second is to find the number of particles. So to find the mole, we must first know the molar mass of aluminium. Okay, so since aluminium is just one element, its molar mass is the atomic mass. So we are going to say aluminium is equal to 27 grams, since that is the atomic mass or the molar mass of aluminium. So to find the mole, we are going to say 6.3 divided by 27, which is going to give us 0.23 moles. So to find the number of particles, we are going to use the formula that says a mole is equal to number of particles divided by the Avogadro's number, which is 6.02 times 10 raised to the power 23. So to make the number of particles the subject of the formula, we cross multiply and we get number of particles is equal to mole times 6.02 times 10 raised to the power 23. So to find the number of particles, so we are going to say 0.23 times 6.02 times 10 raised to the power 23, which is going to give us 1.4 times 10 raised to the power 23 particles. So that's all about the mole. So now that we are done with the mole, now let's go into the percentage composition. Okay, so how do you calculate the percentage composition? Let's say we have a total of balls. Let's say 10 is the total of the number of balls. That means 10 is equal to 100%. So let's say that 9 will be how many percent? Either we say 9 over 10 times 100%, which will give us 90% if we calculate it. Or we say if 10 is equal to 100, then 9 is equal to x. And when we cross multiply, we solve further, we will still get to 90%. So you use this formula to calculate the percentage composition. Okay, let's test the question. Calculate the percentage composition of every constituent of calcium hydroxide. So first we find the relative molecular mass of calcium hydroxide. So calcium hydroxide is CaOH2. So the atomic mass of calcium is 40, while the atomic mass of oxygen is 16, and the atomic mass of hydrogen is 1. So since there is just one atom of calcium, we are going to say 40 times 1. And the 2 outside the bracket multiplies everything inside the bracket. So we have 2 atoms of oxygen and 2 atoms of hydrogen. So we are going to say 16 times 2 and 1 times 2. So we have 40 for calcium, 32 for oxygen, and 2 for hydrogen. So the relative molecular mass is 74 grams. So to get the percentage composition by mass of calcium, we are going to say 40 divided by 74 times 100. We are going to get 54.1%. So to find the percentage composition by mass of oxygen, we are going to say 32 divided by 74, since that is the total mass of oxygen in the compound, times 100, which is going to give us 43.2%. And for hydrogen, we have 2 divided by 74 times 100, which is going to give us 2.7%. So now that we are done, just in the blink of an eye, I've told you how to calculate the relative molecular mass, how to calculate the mole, and how to calculate the percentage composition of any compound. If you enjoyed the video, don't forget to like, and if you want to see more of my videos, don't forget to subscribe and turn on the post notification. And if you've subscribed already, a big thanks.